Nullspace Prep journal files, often referred to as Nullspace Prep scripts, are text-based files that contain a series of commands and instructions used to automate tasks in the Nullspace Prep software. These journal files allow users to record and replay their actions, making it easier to reproduce complex simulations, perform parametric studies, and streamline their workflows. Nullspace Prep journal files offer a wide range of capabilities. They enable users to create complex geometries using various modeling techniques, such as Boolean operations, sweeping, and extrusion. These files can also generate high-quality meshes with fine control over mesh sizing, refinement, and smoothing. Additionally, Nullspace Prep journal files facilitate material assignments and creation of excitations for Nullspace EM. This video will walk through an example of a Ka-Band horn antenna. Ka-Band standard gain horns are widely employed in defense and aerospace applications, including satellite communications, radar systems, electronic warfare, missile guidance, UAVs, and aerospace research and testing. The example will begin with importing a step file into Nullspace Prep, defeaturing the horn, creating a launcher geometry, assigning materials, and ends with meshing the horn. The result from this example will be a meshed Ka-Band horn antenna ready for analysis with Nullspace EM. This example targets a WR28 10dB standard gain horn. The manufacturer provides a step file for this geometry. However, the detailed feed structure is not provided since this is typically highly proprietary. There is also quite a bit of geometry that needs to be removed, as it is not impactful to the simulation. The goal is to construct a model capturing the horn antenna geometry and couple it to a suitably designed coax to waveguide launcher. The frequency range is the standard WR28 band, 26.5 to 40 GHz. Open Nullspace Prep and set the working directory to a folder of your choice for completing this example. We'll begin with a reset for best practice. The View ISO command is used to visualize the geometry and mesh of a 3D model from an isometric view. Next, we will import the step file with an import step heal. This command is used to import a CAD model stored in a step file format and perform healing operations on it. Healing operations are used to fix or correct any issues or inconsistencies in the geometry of the imported model. Then, we will align the back face of the launcher with z = 0. From here, we can now remove all surfaces that don't directly impact the overall simulation of the horn. After that, we can now add a back wall to the launcher section. This example assumes a 50 ohm coax feed based on a 1/100th of an inch diameter center conductor. The feed pin includes a top hat and a matching pin is added to the top of the launcher. The geometric parameters of each were chosen to achieve a return loss better than -10 dB across the operating band of 26.5 to 40 GHz. Now we will construct the coax feed geometry, beginning with the feed pin and then the top hat. After executing the following commands, we can see there is a small space left for the voltage source feed to be constructed. In Nullspace EM, voltage sources are represented by the split strip feed method. Voltage sources require two surfaces sharing a common edge. We can recreate this method by building the surface representing the feed and then splitting it in half. This way, both surfaces remain topologically within the same volume and can be easily manipulated using Nullspace Prep syntax. To build the voltage source, we will first create the strip, capture the volume and the surface IDs associated with the strip, and move it into the proper position. Then, using the split surface command, we can split the surface into two equal-sized surfaces. The syntax of the split surface command is split surface ID across location x1, y1, z1, location x2, y2, z2. The matching pin can be constructed in a manner similar to the feed pin. The cylinder created is rotated and moved into position. As the final step of the CAD creation in Nullspace Prep, the geometry is imprinted and merged. This step ensures that any overlapping surfaces are properly accounted for, and that meshing will be performed to properly yield a watertight mesh. Since this model has both fine-scale and large-scale features, second-order basis functions provide a good balance of accuracy and efficiency. Therefore, the mesh is generated with a target maximum mesh edge length of λ/6. 9-node quad elements are used to ensure a good geometry representation is captured throughout the model, particularly in the high curvature regions of the pins. This model has 5 unique geometry elements that must be configured. All volumes are assigned to PEC. Then, the voltage source top and bottom surfaces are used to create a voltage source named port. For best practice, we will do a delete mesh and reset surfaces and curves. Since this model uses a voltage source excitation, the curve common to the voltage source surface should have a single mesh edge. Similarly, due to a limitation of the quad mesher, the curve common to the bottom of the voltage source and the waveguide should have at least 2 mesh edges. In the vicinity of the feed and matching pins, the geometry should be well captured by the mesh. Thus, the mesh size is determined based on the pin's radii. The launcher surfaces are meshed adaptively to provide a smooth transition from the fine to the large-scale geometry features. All remaining surfaces correspond to the horn body and should be meshed at the maximum target mesh size. Now that the mesh is complete, it is helpful to perform an assessment of the mesh quality. A mesh quality of 1 represents a perfectly square quad element. A mesh quality of 0 means that 1 or more quads are malformed, and further mesh diagnostics are required. We can save this surface mesh as a cub5 file, the native file format of Nullspace Prep. Saving meshes as cub5 files ensures a lossless representation of the original mesh data. For further reference, visit the docs folder of your Nullspace EM installation to follow along with more examples and understanding the different ways to manipulate and mesh objects using Nullspace Prep. Nullspace EM. Built for engineers, by engineers. Thank you for watching this video and check out our YouTube channel for more helpful tutorials, webinars, and demonstrations.